So thank you everyone. I'm going to keep this on time to the 15-minute time slot allocated. But what I want to talk about today is do a bit of a case study on a project we did in New Zealand. I'm not going to go into what digital twins are. I think most people on this call will probably know that. But what I do want to talk about is kind of who I am, in Twinview's approach to digital twins, in a sentence, and then we'll jump straight into the project and give you a bit of background and how we got involved in some of the unique features on this project. And then we'll do a little demo at the end to give you, I think it's always good to show you rather than talk about it. So yeah, I'm Adam Ward, I'm CTO at Space Group, and really Twinview's been my baby for the last few years, and implementing it on projects, and every project's different, and this is a particularly interesting project for me because it's one I'm proud of. It's one where we're doing something quite unique, and it's quite a cool building. So we'll jump straight in. So firstly, Twinview's approach to digital twins is a platform approach. So there's a need for custom built digital twins using gaming engines and things like that. And if you're modeling a system or a process or a production line or air traffic control systems, for example, or airports. But I think what we did with Twinview is we did a platform approach because we wanted to make operational efficiency a priority. And if you were £30 million at school in Hull, you're not going to have the budget to create a digital twin from scratch each time on each building. So what we decided to do was have a platform approach, a platform which can be modified for each building. Now, we do have some really cool buildings on. This isn't one of them. So this is the old Archives building in New Zealand. And essentially what the Archives building was, or is where it keeps the national treasures for New Zealand. So all the history was kept in this building. This is the old building. And as you know, New Zealand is in an earthquake zone and various other issues. So this is the old building, and as I say, it looks like something from the Indiana Jones film. It's kind of where it keeps all the old records, treasures. And up until recently, nobody would tell us what was actually in this building, but I'll give you a little insight into that a little bit later on. But essentially, it's really, it's the most precious Tonga, which is in New Zealand. It's artifacts, essentially. It's all the history. And the Archives has had a bit of a troubled past. It's had various buildings, and it's got a bit of a curse on it. The old building in 1952, a fire ripped through and destroyed a lot of artifacts. And obviously sitting in an earthquake zone, the existing building was deemed unsafe if there was another earthquake. So the government, that's a fancy animation, didn't know I had that in, had put a budget aside to do something about this, to protect these national treasures. And they put a budget initially of a few £1 million aside, which actually this building cost 330 million when we look at it, to do that. And this is the building. So it's designed by Warren and Mahoney architects. It's a really cool building. Essentially everything below the glass is storage, and there's no windows because it's in a sealed environment. The air quality, the temperatures are all controlled, and it's sealed to the outside world to protect the artifacts. And the glass area above are all offices. So think of it as a museum, which it's got really strict environmental controls for humidity, temperature. Really, it's a really high-tech building, probably one of the most high-tech buildings I've ever worked on. And it looks like something from NASA inside here. It's all white rooms where you have to walk through double chambers to decontaminate yourself before you get to some of these treasures. And the facade is designed to basically control that environment. So it's a really cool design. It's built on top of a historic artifacts. So you can see they built this like landscaping area in here. And also, because it's sitting on a fault line in New Zealand, earthquake zone, the building is designed to move 3 meters or 1.5 meters in either direction. I've got a little cool animation there just to give it a bit of. So the building's designed to wobble. It's sitting on big springs essentially, and everything is isolated. Pipes are all have movement from isolated to basically allow the building to move 3 meters each way. And when I ask people what's in this building, people who have worked on the project for years, I couldn't get a straight answer, lots of paper books and stuff, like something from the Indiana Jones film. And apparently you have a feather of some significance. So this is, until a couple of months ago, this is kind of all I knew. But I did know it was a really high-tech building, so whatever was in there was really, really valuable and really important to New Zealand. So it has got the world's most extensive feather. So this is multi-millions pounds, and it's from an extinct New Zealand bird. But also some historic paintings from essentially the New Zealand's independence. So when the deal was done, but also the equivalent of the independence. So these are like the original documents when the British basically handed independence back to the natives there. These are kept in this building. And here's a screenshot from Twinview. You'll see the whole building is isolated on these dampers. So this is all rubber, and the whole building can move 3 meters. So all the pipe work's isolated with movement, elastic joints, etc. And the whole building can wobble 3 meters. You can see the pads there for the building. You can see the lift here. So obviously the lift is suspended from the roof, and it's actually, yeah, the lift, because obviously if the lift was come from the floor like a traditional lift, it wouldn't work if the building moved 2 meters. So essentially the lift is suspended and the whole building is sitting on big springs, big rubber springs, and it can move 3 meters. So there's lots of sensors on this building monitoring that, because the idea is if there's an earthquake, this building could be back up and running without getting a report done. So typically in New Zealand, if an earthquake, you have to get engineers to come and inspect it and sign it off before it can be used again. This building can be up and running without any of that. And it, like I said, high-tech offices. So what I'll do is I'll jump into it. I want to see my pull this up. So this is the building in Twinview. So what Twinview essentially does is bring all the information together. And like I said, this is really for facilities management and operation of it. So if I go and click on any bit of equipment, let's find a better view here. And I'm going to show you some of the real data we've got coming in here as well. So if I go down to find something that looks exciting, let's go in here. So if I go and click on a piece of equipment here, and I go and click on the properties, I can get all the data for the equipment. We can see it, we see all the manuals, etc., put all the O&M information together. So it's a single repository for all this information. But if I click on dashboard, we can actually see what that piece of equipment is doing. It's got a full facilities management system. So that was the idea is that you wanted to understand and manage the assets, not only the artifacts, but also the equipment themselves at quite a high level. So if I went to, let's look at AHU. So I'll go into 7.5. Yeah, what we can see is see all the data, and if we click on dashboard, we can go and see what that air handling unit is doing pretty much in real time. So thousands of sensors in this building, and we can see what it's doing as of a few seconds ago. We can actually go and find that if we wanted to, and pull all that information up, all the drawings, etc. Now in here, we've also got all the rooms. So if I wanted to go and see one of those storage areas where you keep those artifacts, let me just turn my section box back up. Again, you don't need 3D models for a digital twin, as I'm sure a lot of people here know, but it does make it useful if you want to go and navigate the systems, etc. So if I went into, let's go into rooms, collections, because that's where you keep the good stuff. So let's go into collections, 3.2. So here's the room. We can go and locate that room. You see it's a whole floor level. And if we go in there, we can actually go and see what that room's doing. So what we can see here is the temperature of the room currently, and it's pretty constant because it only fluctuates because it's such a highly controlled environment. The maximum it can be is 21, the minimum can be 15, and it's predicted to be today go up to 18.2 as a maximum, and it's based off dynamics. So it's monitoring the temperature, and it's basing the baseline either side of that to see if it goes out of range and providing that. And of course, if it does go out of range, it raises a ticket in the FM system. Unfortunately, it doesn't yet control itself to fix that problem. It still all goes back through the FM platform, which is built into here. So if I go to facilities management, we'll see in here, you can see tickets, issues. I've got to be careful what I click on because this is the project. You'll see on here, additional power sockets. Going on, we've got some tickets raised here. We can go and see it, see the information. and we can see all the jobs. If I wanted to go and see some historic maintenance, every single aspect on this is logged. So I go in here and I go into this one's in progress. Let's have a look at that. I can see the information. I can see who's doing it. I can see all the information that involved about this, if it's got an asset related to it, which it doesn't. We can see all the information that's currently in progress. And all this information is kept against all the assets. To show you what I mean by that, and then I'll stop for any questions. If I want to go and find a pump, let's go and find a pump. Should be a pump in the building, I would suspect, or a building of this. Yeah, heating. This heat pump, I'll do. Locate that, there it is. And if we look at that now, we click on jobs, we'll see all the jobs coming up. Annual inspection, so it keeps all this data in one place. And again, if there's any real-time data on this pump, we can go and see on here, there isn't on this one, it would actually show that data in there as well. So what we're doing is we're bringing all the information together and we're reporting upon that. And the last thing I want to show is how we, very quick, I'm not going to go into this, but you can see the data coming in through MQTT. And again, I'm not going to talk about MQTT. We're normalizing the data. And then what we're doing is we're doing stuff like raising alarms if temperatures go out of range or the sensors go out of range. So yeah, and the really cool thing about this building is, which I thought was quite unique, is that earthquake seismic sensors, it can actually detect wind blowing on the facade and the rotation of the earth. It's that sensitive. And you have to counteract for that in the actual readings, which we put into TwinView. So it's super sensitive. And the idea is it's always logging that activity. So that's a little brief introduction to the project. I don't know if there's any questions. I'll quickly jump back to my slides because I think I've got one more slide there. But yeah, so really what this is an operational digital twin. It's taken lots of real-time data, operational data from facilities, how the assets are maintained and how the equipment's maintained, and constantly reporting that back to the FM and operational team who are then responding to that. And it's keeping a full log of all that information. And yeah, so I don't know if there's any questions or any information about any questions on any of that.
So the question here is, what did you learn from this project and what do you wish you could have done differently?
So I think what on this project, the hard work was really done by the rest of the consultants. The architect had a really powerful model with lots of data in, and everyone was working before we got involved to make sure it was structured and the information was in there. I think what we would have did differently is who was left out of that was the operational team, the facility management team. They came in because they went out for tenders to different companies. They came in towards the end. So kind of we had to do lots of changes to suit their workflows and their systems. So it would have been better to speak to what the FM team do and how they operate the building and build that into the data we have in there to allow that to be more seamless. That's what biggest thing we learned.
Very good, thank you. Next question is, can you talk us through how easy it is to implement some of the advanced features you've talked about? Can they be implemented for other projects?
Certainly. I mean, we built TwinView as a platform, and everything you've seen in there, you can do without being a coder or a programmer. You don't need to be particularly technical. You need to have the right mindset, but you don't need to necessarily understand building ontologies and stuff like that. We handle that behind the scenes, so you can upload any type of model, 150 file formats. It understands the structure of the data in there, even if it's not perfect. But the more work you do, the better it is and easier it is. But yeah, we built ours to be, because we've come from what I'll call the background that we're not software developers. We've come from the industry as a BIM consultant essentially, and we've developed this for our clients, which is now a commercial product. We knew the problems and we built to solve those problems. So we handle all the clever stuff behind the scenes, the hard stuff. You don't need to understand databases and NoSQL databases and big data kind of manipulation. It just handles it. I could talk about that forever, but I think if you want to follow up on that, drop us an email and we can go into a lot more detail on that and actually show you how easy it is. But yeah, there's always a need for those custom built digital twins. But what I would say is we've designed this to get up and running really quickly, and that's what we're quite proud of. Yeah.
Perfect, thank you. Next question here is the level of modelling down to individual M&E components is impressive. Did you go into a greater level of 3D modelling for the building and its plant components, or was this naturally available from the design process?
So this was naturally available. So I think the design team, particularly the client, demanded it from before we were involved, and they set out clear about what assets they classed as maintainable in like an asset information requirement document, and the design team worked to make sure that data was in there and the data was correct at the end when it was in there. So really the hard work was done by the team. They had a really detailed BIM model. Again, you don't need a BIM model. You could import data into Excel if you wanted, but yeah, it was really well structured. It was good, and it made up my job a lot easier. So yeah, the more deep. Well, my argument is you don't need a 3D model, but there's no better 3D. It's not better to hang the data on than the building itself, because that's what people understand. It's the natural. And every building is structured the same. Every building's a building, has levels, has rooms on levels. It kind of follows that methodology, so it kind of falls into place. Yeah. But yeah, you definitely don't need the level of detail in this model. You could get away with no model, or even like a slimmed down light model. Yeah.
Yeah, so I guess it could be an asset process system and the level of detail proportionate to your use case. So
Exactly.
digital twin is not the 3D model. The 3D model is a visualization of the digital twin. There you go. Next question here is the system real-time delivering? Which technology platform framework are you using, and what processing computation are you using?
Yeah. So we do our data ingestion, normalization, and transformation on the edge. So Twinview's cloud-based, multiple, but obviously software as a service. It'll be bad design to send. So that building you've seen there sending us 380 messages every second. Every second we receive 380 bits of data. And what I'm going to retire on, so I'm not going to tell you how we do it, is basically we can store that in the database while making the database bigger, where normally in a database, be like adding a row to it. And you can imagine 300 points every second over years makes that database huge, slow, clunky, even within the SQL database. So we've got some quite proprietary tech, but what I would say, it is based off, yeah, no SQL, like MongoDB, for example, but we do some clever stuff on the transformation and the processing of that to make it lightweight, but it's all based on AWS infrastructure. Yeah.
Cool. Which part of the project are you most proud of?
For me, it was actually getting, because on every project we work on, you always get the FM people sitting like this, because you kind of want to do it the way they've always done it, and you think it's going to catch them out. Why do you need all this information? Why is it more work for me to do? Because there's a bit more work for the FM team. But what I'm quite proud on this one is we turned everyone around. So now even the FM company who kind of said, why are we doing this? It turned around, and it's proven value. It's really hard to prove a value of a digital twin until after a number of years, but this has been live for 6 months and we already seen value. So that's what I'm particularly proud of, is kind of how we've managed to get everyone on board without any fights, which sometimes you have to do. Yeah.
Very good. I'll find a couple of questions here. Is this type of system easily scalable? Can an airport terminal, for example, be scaled to? Do you have a process of prioritizing which data streams would be critical, and what is the level of information required?
Yeah, so this is what we would normally do before we get too deep into a project, understanding the client. There's real-time data where you want to know instantly, hey, there's an alarm going off, something is out of range. You need to know that instantly. There's a fire. You don't want to wait 5 minutes till you get the next data load. And then there's other data where temperatures, you don't need the temperature every second in a room necessarily. So it's understanding that, and then that's when the transformation and normalization come through. So there's a process where, we know off-the-shelf room temperatures. Unless it's a very specialist building, you don't need the data every second. Give us it every 5 minutes. Instantly, you're saving a lot of resource, a lot of processing power, and a lot of storage. So instantly, not a problem. But we tweak it to suit every project. But as you saw on that flow I showed earlier, that's the transformation. Data comes in, we normalize it, we transform it, we basically process it.
Yeah, and I think this next question, you've partly answered in your response just there, but could you see this being scaled in the next 10 years to places with high facility demand like labs, or is this not financially viable? So back to the scalability question, if there's anything else you want to add.
Yeah, I think scalability is obviously you shouldn't be storing data or processing data, because when you're processing anything, it's bad for the environment. It's running something in a data center. And again, more data. I'm doing a lot of research in machine learning at the moment, which is coming into Twinview shortly, getting released publicly in Twinview shortly. It's beta testing now. Yeah, when you need that, you need clean data. Too much data, longer to process, more to train. So it is important you get the data correct. But yeah, it's definitely scalable. And like I say, we've got some. I'm going to tell you on it, the technology we've got, which makes it scalable without making the cost go up. It's what I'm particularly, nobody else cares apart from me, but I'm quite proud about that because it's quite a unique innovation, I think. Yeah, we don't really worry about the amount of data. It's more about kind of processing the data. When it comes in, you've got to process it. Storing it's not a problem for us. We can store how much data you want forever. It's more about how we process the data when it comes in. More data coming in real time per second, the more you've got to process and normalize. And that's where the bottleneck would be, if there was any bottleneck.